Okay, so hi everyone, Senan on this side, and in this video we are going to discuss what is exactly the selection sort algorithm. Okay, so the previous video was on bubble sort. If you want to know that, you can just find that on my channel. But okay, what is selection sort? So what like bubble sort, we had an example of a container, right? So in this selection sort, what I would tell you is, let's say you have a bookshelf and you have some books in it, right? This is your book collection and you want to sort this on the basis of the height of the books. So what do you do? What do you do is you find the book which has the minimum height, let's say this one, and you swap it at the correct position. You place it at its correct position. Okay, once you've done this, what happens is the smallest book is here and the first book is basically swapped. Now you check all these books and find the book which has the minimum height, right? So in this case, this has the minimum height, so I will swap this book with this book. So to do that, let's take this and this, right? And similarly we will find from this point onwards, or let's say this point onwards, I would find the book with the minimum height and place it at this position. So by the end, what you would be having is a book that is sorted in increasing order. That is the whole logic. So let's take a sample example and run this algorithm. So let's say you have this array of 6 elements, and let me just choose some random numbers. So 42, 37, minus 1, minus 100, 72, and let's say 60. This is our random array. So for this, I'll initialize a min value, and min value would be what? Min value would be the value at the very first index. Let's say this position is I. So min is at position I and the value is what? 42. Now I'll take a j and I'll traverse this list towards the right. Assume that we are sorting in ascending order. Okay, so so j would start from here. So this would be j. I'll check, is the value at j less than the minimum value? So is 37 less than 42? So that is true. So I'll change this 42 to 37. Okay, so my j goes here. Is minus 1 less than 37? I'll compare this with the minimum element, right? Is minus 1 less than 37? So that is true. So I have to update my minimum variable, and that would be what? That would be minus 1. So I change this to minus 1. Okay, now my j was here, so now j goes here and sees it's minus 100. Since minus 100 is less than minus 1, so we have to update minus 1 as minus 100. Okay, so now j goes here and j sees we have a value of 72 and it is greater than the minimum value that I have currently seen till now. So I won't do the update on minimum. So minimum stays as it is. Now we go to 60, right? So 60 is less than minus 100. That is not true. So we don't update this minimum variable. Now what we do is we have our minimum element at, so the minimum element is -100. So what I do is, rather than storing the minimum value, I would store the index, right? So this is 0, 1, 2, 3, 4 and 5. So rather than storing the value -100 and or 42 or 37 or -1, I would be storing the index. So the index of -100 was 3. So what I do is I swap this, swap array of I with array of minimum. This is the operation that I am going to perform. So what will happen is -100 would come here and 42 would go here, right? Or let's say I'll basically create a copy of this array so that it is easier to compare. Okay, so what I do is I update the values. This is what 42, this is -100. Now observe the minimum element. We are finding the minimum element of the array. We are selecting the minimum element of the array and placing it at its correct position, right? Now after we are done with this, I'll just move this iterator one step to the right and I'll reinitialize the minimum variable to 37. Now I check, now I'll put j here and I'll check this value. So is -1 less than 37, right? That is true. So rather than storing 37, we will be storing the index, right? This is value, this is index, right? So what we do is we initialize j as I plus 1. We see is -1 less than 37, that is true. So what we do is we make an update. So the updated value is -1 and it is at index 2. Fine. Now again I check here, j goes here, I check is 42 less than -1, that is false. We don't do an update on the min. Again I go to this value, I check is 72 less than -1, that is false. So again I go one step ahead, I check is 60 less than -1, no, that is false. So what I do is I don't update the min value. Now my j is here and I'm done with this iteration. So what I do is I swap 37 with -1. So copy and paste. Now if that is the case, I just interchange the values. This is -1, this is 37, and if you see, the second smallest element is at its correct position. Now I change this I to one step ahead. Now I initialize j here and min value is 37 and it is at position 2. Now is 42 less than 37? No, that is false. We don't do this update. Now j goes here. Is 72 less than 37? Is 72 less than 37? That is false. Again, I would take this j, move it one step ahead. Is 60? Is 60? Oops. Is 60 less than 37? No, that is incorrect. So what we do is we swap 37 with 37. So basically we don't do anything. Okay, so in the next iteration, what we do is we take this I and place it here. Take this j and place it here. And we initialize min as 42 at index 3. Okay, is 42 less than 72? That is true. So we don't update the minimum. Push J one step ahead. Is 42 less than 60? That is true. So we don't update the minimum as well. Right? So again, we are done with this iteration. I just take this, copy, and paste. Now this I goes here, and we set the min value as 72 at index 4. So J is at I plus 1. So is 72 less than 60? No, that is false. So that means we have to update this min value. So this would be equal to 60, but at position 5. Now what we do is we swap these elements. So in the end, what we would be getting is copy and paste. So in the end, I would have 60 here and 72 here. So this just means that since I is at position n minus 1, n minus 2 basically, if n is 6, so I is at n minus 2, and after doing this we just terminate the algorithm. As you can see, we have these elements in ascending order. Okay, so how would we go about writing the pseudocode? Let's say function selection sort, and the input would be an array. Okay, so first of all you need n, which is equal to array dot size. First you get the size of the array, and okay, so if we see, we started I from 0 and it goes till n minus 2 inclusive. So for I equal to 0 and goes to n minus 2, this is inclusive, and we do something, right? We find the minimum element of this array and then we do a swap. So what I do is, for j equal to I plus, or rather than before this, we initialize the min value as, let's say min value as array of I. Now I traverse the whole matrix or whole array. For j is equal to I plus 1, j goes to n minus 1. So 0 based indexing, I am assuming that. So what I do is, if rather than storing mini as array of I, I'll just store I, the index. So if array of I, or rather than array of I, but array of mini is greater than array of j, what I do is I set mini equal to j. So what am I exactly doing is, if I see an element which is smaller than the minimum element that I have seen till now, I update the minimum element. Okay, so after I'm done with this for loop, what I do is I'll perform a swap of what array of mini with array of I, and we close this for loop and close this one and return the array itself. Fine. So the whole logic is we start from I is equal to 0, initialize the mini as I, and what I do is for the remaining elements in the array, I find what is the location of the minimum element in the remaining array, and then I just perform a swap with the position I with the minimum element. So this is the selection part, and this is through which we are sorting element by element, right? So that is why this whole algorithm is known as selection sorting or selection sort. So this is about it. Now if you see if you try to discuss the time complexity, what would this be? So let's say we have an outer loop running for n-1 times, right? You start from 0 and go to n-2, so there are n-1 iterations of the outer loop. And how many inner loops are there? Inner loops are n-1, or let's say n-1. So we are starting from j is I+1 to n-1, right? This is about linear time, so it would be order of n, and the outer loop would also be order of n. So if you multiply this would be order of n square. Okay, so if you find this confusing, why order n? Because the inner loop for the first element, we are traversing n-1 elements. So for element 1, we are traversing the remaining list for n-1 times and comparing the elements. For 2, we are doing n-2. 3, we are doing n-3. And as we go on, at some point we would reach this 4, 5, 6, n-4, n-5, and at some point of time this would reach 3, 2, and 1. So these are the number of operations that you actually did. So what you do is n-1 plus n-2 plus n-3 ... 3 plus 2 plus 1, and if you take the sum, this would be n-1 by 2. So this is order n square. That is how we got order n square. And space complexity is constant. We are declaring a mini, and j and I and maybe n. So the space complexity is of constant time. So that was this video was all about. Hope I was able to explain you. It would be really appreciated if you share this video with someone who maybe requires this video, right? Anyways, thanks, and I'll see you in the next video for insertion sort.